And with that, I'm going to hand it off to Sayan. Sayan, I think you're unmuted. You're ready to go.
Yeah, hi, Seth. Yeah, thank you. Yeah, hello, everyone. So I hope I'm audible and my screen sharing is working fine. So
they are, yes.
Okay, yeah, thank you, Seth. So yeah, so this webinar is regarding a very, a basic introduction on how we are doing the load balancing in TrueSight Operations Management. Okay, and so we'll start off with that. So the overview of the agenda of the webinar would be basically why and what is the load balancing, and trying to explain, touching on the types of load balancing, and then moving on to configuring the load balancing in the TSOM environment, and then finally ending it up with some advantages of the load balancing, and then the question. So let me just start off. So the basic question which comes is, why do we need to use load balancing in the current enterprise world? So as we know, like there are, in an application server, the enterprise server, the websites related to the app server, it gets multiple hits, okay, in a very short span of time. So this, what it does, it makes the application really heavy and finally impacting the performance. So one of the ideas is to distribute the load across multiple server in these kind of scenarios, okay, and this is where the load balancer comes into picture, where it does the load distribution so that we don't depend, or it actually doesn't depend on one single server, and it doesn't get impacted. We end up getting a high reliability, efficiency, and availability of the application, okay. Now, why use, so basically using the load balancer in a TSOM world, mainly from the TrueSight presentation server, we plan, it's mainly because of that high availability. The same goes with the infrastructure management server. We do that high availability. That's one of the major reasons we are using the load balancer in the presentation and the infrastructure server. Now, using the load balancer in the integration services, that is the ISN, one of the main reasons would be we try to reroute the incoming traffic from the ISN to the specific TSIM. Okay, so that way, at the ISN end, we try to balance the load to which TSIM it goes, depending on which is the active one. So this is more or less an overview on why we are using the load balancing. Moving on to the next slide. So now, what's the main advantage of a load balancer in the TSOM world? So one of the main things that I said, so avoiding a single point of failure. Let's say, the primary crashes, so we have the backup of the secondary server to take up the job. So evidently we are avoiding sort of a single point of failure. Then another thing, we make use of this abstractions, because normally the load balancer, we connect it through the virtual IP, and we actually abstract the actual IPs, the internal IPs, and the physical machine names. So that's very, very internal to a customer and the end user environment. Now, then some of the reasons would be that high availability for both TSIM and the TSPS at the application level, and then coming to the integration services, as I pointed out earlier slide, so there will be a workload reduction, when routing the traffic through the integration services. So in that way, we are balancing the load when we are using, we are doing sort of a workload reduction when we are using the load balancer with respect to the integration services. The couple of other things that is advantageous is the resource usage is efficient, and that's again guaranteed on the kind of load balancing algorithm that we are implementing. Then of course, last but not the least, we have the inbuilt health monitors, which actually does a passive monitoring of the application. So it detects, which is actually the active one, the application in the TSOM primary and the secondary server, which is the active one at one point of time, and then it makes sure that the requests get routed to that specific application, that is the primary or the secondary server. So moving on to the next slide. So these are types of load balancing. Overall in the current enterprise world, so we have it's broadly bifurcated into two sections, that is the software and the hardware load balancing. The software load balancing is basically we install it on the server itself. As we can see, it's a software, right? So the drawback is sometimes, depending on the load, it would of course consume the processor utilization where it's installed. Okay, it consumes the CPU cycles, and it's again implemented with one of these three algorithms: either the weighted scheduling algorithm, the round robin, the least connection first, that is the LCFS. And then we come to the hardware load balancing. So that is basically dedicated, a set of routers or switches that is placed, we normally place it between the server and the client. And it's normally implemented on the OSI layer 4 and layer 7. So basically layer 4 being the transport layer and layer 7 being the application layer. So now this slide is just to give an overview of the types of load balancing that is there right now and being used in the current enterprise world and also in the TSOM world. So we use one of these loads. So you can always go ahead and use a software load balancer like an Nginx or a HA proxy, or you can always use a hardware load balancer like an F5 or Big I. So these are basically the types of load balancing that we relate to in the TSOM world also. So I just move on to the next slide. Now, these are some of the terminologies that is used in the load balancer configuration and in fact in the load balancer world itself. It's nothing very specific to TSOM. It's like a normal load balancer, enterprise environment. These are the things that needs to be configured, and these are the terminologies that we will be using. And the same thing we used in the TSOM world also. So for example, the node. Now, this is nothing but a logical object on the load balancer systems. Its main purpose is it actually identifies the IP address of the physical resource on the network, and we can explicitly create the node, or we can also instruct the LTM or the local traffic manager to actually automatically create one. When we add a pool to a load balancing pool. So then that takes us to the terminology load balancing pool. So this is again a logical set of devices. It can be a web server that we need to group together to receive and process some traffic. Okay, so that is basically a load balancing pool. Now, instead of sending the client traffic to the destination IP address specified in the request, in the client request that comes in, the LTM or the local traffic manager sends the request to any of the available servers, which are actually the members of the load balancing pool. So basically it decides that in the pool, whichever servers are there, which is the one which I should be sending this traffic to. Then again, we come to the concept of health monitors, which I was speaking to previously in one of the previous slides. Like its main function would be to make sure that the load balancer is actually operating seamlessly and it's able to route the traffic to the nodes that are in active state, or maybe we can say like the nodes that are actually functioning properly. So that's the main use of the health monitors. So the load balancer is actually identifies which is the active node by using this health monitor, and then onwards the traffic routing is done. Then we come to the terminology of virtual server. So basically it's actually a traffic management object on the LB system, on the load balancer system itself, and it's represented by an IP address and a service. Okay, so basically the main purpose of a virtual server is often to balance the traffic load across a pool of server on an internal network. So the clients on an external network, so basically they can send the application traffic to the virtual server, which will then route or redirect it to whatever configurations that we have done in the virtual server configuration. So these are the terminologies that we use in the load balancer world, and also directly we can relate these terminologies in the TSOM world that we use and we configure. So I'll just move on to the next slide. So now I'll just give you a very brief overview of configuring the load balancing in the presentation server, TrueSight, and the TrueSight infrastructure management components. Okay, some of these slides, it needs, since there's a configuration slide, so some of this has some detailed information. Okay. So the first slide is actually an overall pictorial representation of how the load balancer is placed in a TSOM, at least the operations management environment. So either we start from the top or from below. So if you see, we have the RSSO. So the RSSO, they are in a load balancer, and then if you go to number 2, then we have the TSPS servers in the load balancer, and likewise we have the infrastructure management servers in the load balancer, and then the ISNs are also actually behind the load balancer, and then the traffic to the ISN, that is the petrol agents, it's actually not directly going to the ISN, but it's actually going through this load balancer. And then the load balancer is the one which decides which ISN I'll be routing the traffic to, depending on the algorithms that we select over there. So this is an overall pictorial representation of the load balancer placement in the TSOM world. Okay, so the next few slides will show how to configure. Okay, and so this slide is just I just want to talk about that, how we are achieving the load balancing in the TrueSight presentation server. So if you can see below the diagram, so we have the primary and the secondary presentation server, and the green line is actually, it indicates the active workflow. So that is the one, the node that is actually the active one, and the red line is the one when the active nodes crashes or the failover happens. So that is the one it actually fails over to. Now the point to note over here is in between all these things that is going on, so parallelly there's a replication between the primary and the secondary presentation server. So even if the primary presentation server is inactive and the secondary is inactive or in the passive state, but still there will be a continuous replication of the database and of the events of the data, okay, from the primary to the secondary, so that when the failover situation happens and the load balancer decides to route the traffic to the secondary, we don't see any kind of a mismatch in the data, be it regards to events or be it regards to any kind of data. Okay, so that's the reason we don't this continuous replication happens. So I think there's a question in the chat window. Let me just, okay, maybe we'll take these questions at the end of the presentation. Okay, so So this is a pictorial representation of how we are doing the load balancing in the presentation server world, okay? And the replication is one of the major important factors in the to make a note of, okay? I'll just move on to the next slide. So now this is how we are configuring the TSPS load balancer. So for this webinar, we've taken the F5 as an example, and that is something we've also used also and tested, and that's why we thought of taking this as an example. So this screenshot that you'll see, these are most all taken from the F5. Okay, so many of you might be using some other load balancers, okay, but more or less the procedure and the logic behind adding or configuring should be the same. Maybe the screenshot names or some of the details would differ. So this is how the home page, when we log into the F5 load balancer, it will look. So we've just grayed out, we've just disabled the host names as per company policy. Okay, so and then so this is the main the home page, and then moving onward, we'll see how to configure the nodes, the health monitor, the pool, and the virtual server. So this is the screen where we are configuring the nodes and the health monitor for the TrueSight presentation server. So for the nodes, we need to from the home page we click on the local traffic, and then we get the node list, and then we click on the create. So some of the mandatory informations like the name and the FKDWN, the address of the FKDWN field, we need to fill it up, and then we just click on finish and creating a new node. So the same steps we should be following for the standby node also. Now, while creating the health monitor, the same guidelines hold true. Okay, we would need to select the type as HTTPS, and one important point, in fact, two important points that I'd like to stress over here is, if we are using the TrueSight 11.x and higher versions, then the send string would be as mentioned here with the logout user.jsp. Okay, and if it's pre-11.x, like for 10.7 and lower versions, so it would be the get HTTP host connection URL that we've mentioned, that should be given in the send string. The receive string remains the same. It's HTTPD 1.1 200 for both the cases. So this is where we are creating the nodes and the health monitors on the TrueSight presentation server. So now we are creating the pool on the TrueSight presentation server. So that is the load balancing pool. So it's the steps are, once we log into the home page, so it's very self-explanatory. The steps, you just click on the pools and click on create, and we just enter the name and select the health monitor created in the previous step. And for the new members, we just select from the drop down, and we need to, so whatever the primary and secondary nodes we created in the previous slide, those we need to select. So the port number would be 443 for a Windows version of TSPS, and 8043 for TSPS on Linux. So that is where the pool is done, and then we go to the creation of the virtual server. So most of the steps are almost same and self-explanatory. From the F5 home page, it's all under the local traffic virtual servers tab. The only one thing is we need to use the type as standard and the source field giving the 0.0.0.0. So these are some of the things we need to make note of if we are using the F5. And so the configuration, so we need to select HTTP for the profile field, And under the resource tab, so we need to, from the drop down, we need to list and, select the pool that we just now created before, in the previous screen, and then just click on finish. Now, one thing I'd like to, mention here is, so as I said, these screenshots are taken from F5, but most of these terminologies, okay, would be remaining the same even if we are using any other load balancer. It may not be identical, but the logic remains the same and the configuration steps more or less remain the same. So this is to be done with the TSPS, and we have the command line options where we need to add some entries from the bin path on the TSPS machine. Okay, we need to make sure that we set the proxy hosts and the host lists, and then we need to also set the load balancer name and then reload the properties. Okay, so one thing is all these names, everything should be in the FQDN format. Okay, otherwise it won't take effect. So that's in fact our recommended way, because in the TSOM world, in the presentation server, we rely on FQDN. Now we come to the TSIM, that's the integration service management components, where we are creating the nodes and the health monitors. So the steps are mostly the same, okay, as we've done for the TSPS, and we need to repeat the same steps both for the primary and the secondary node. Okay, in the health monitor, there's a slight difference in the TSIM case. So if we are using 11.0, 11.x and higher versions, we need to give the show error JSP URL in the send string, okay, and for versions 10.7 and below, it's the login.jsp. The receive string still remains the same as HTTPD 200. Okay, and then so the creating of the pool, again the steps are same. From the pool list, just click on create, and then we need to select the health monitors created in the previous step. For the new members, we need to select the node list, and then the drop down, we just created 2 TSIM nodes in the last slide. So the same thing we need to select over here. Again, the port remains 443 for TSIM on Windows and 8043 on the Linux. So after that, we just click on add, and we are done with the node with the pool creation. Then we come to the virtual server creation. The steps are identical, but except for a couple of differences, like we need to use the type as the performance layer 4. That is one difference between the the TSPS and the TSIM. So the rest of the steps are almost the same, and we should be okay to click on finish and create the virtual server for the TSIM. Now we come to the command line configuration of the TSIM. Now there are two things, like if the HA enable is already executed, then we need to go to the custom conf, and then we need to append the virtual server name in the FQDN format in the conf using the below property. So this is the tsim.proxy hosts, and and then the FQDN of the F5, and also we need to set the ha.cluster name. Now this would be again in the same directory in the file called ha.conf. So after this, we need to save these files and restart the TSIM. Now this is the case, or this is the scenario where we've already done an HA enable, but after that, for whatever reason, my LB name has got changed, or for whatever reason the LB, the host name has got changed. Now so in that case, we are going to manually, we need to update this. Now let's say if the PW HA enable is not executed, then we don't need to do anything manually. We just need to run the command, and it will ask for each of these things, and the LB name we can give the new LB name, and automatically all these files would be updated. So now this slides just touch bases on the load balancing, the TrueSight integration services and cells. So as I was telling in a couple of slides back, as per the pictorial representation, so we are having the ISNs behind, or the TSIs behind the load balancer, and the request, the petrol agent request or the petrol agent connection comes to the load balancers, okay, and then as per the algorithms that we've selected in the load balancer, it will distribute that to the active, whichever TSI's process it needs to. Now, what we've seen for a fairly large customer base is about 750 to 800 connections of the petrol agent per TSIS, okay. So also we do have health monitor for the TSIS also, and that is basically created on the port check. The default port that we check is for 3183, and it would just, and we'll just check if the IS is running on this port or not. And so the variable on the PA, the TSI's variable on the PA end should actually have the virtual host name of the TSIs and not the actual host name of the TSI. So that is how we try to do a health monitoring of the TSIs. Okay, and so this is, and then so that's all we have with respect to the load balancing in the TrueSight world. So now I'll just open it up for some questions. I believe there are some questions in the chat window. Okay, right. So
yeah, let me go ahead and so I have everybody muted, but we've asked people to put questions in the chat window. I'm happy to open up the verbal line. So if you want to speak your question, let me know, and I will unmute you. It looks like Prakash has a question. Now, one of the challenges I have here is if you've dialed in on a phone number, that's the only way I can see you in the. So you'll have to tell me which phone number you're dialed in on if you want to speak a voice question. Otherwise, please type them in the. So Prakash, go ahead and let me know what number you're calling in on. All right, hang on just 1 second.
Or maybe, Seth, we can have the question typed on the chat window.
Yeah.
Prakash can, yeah.
He's asked to do it verbally. So Prakash, okay. You should be unmuted now.
Okay, yeah. Are you guys hearing me? This is Prakash.
Yes.
Okay.
Yes.
This is about specifically about it's a great presentation about the load balancing one, specifically the F5. So here we have a deployment. It's a big deployment of the TrueSight Operations Management 11.301, where we have everything front-ended by the load balancer. I never saw any description mentioning about SSL termination. Here we are running in a DoD environment, specifically in the military world, where we need to have SSL enablement everywhere. And the way in which we are deployed is we have two RSSO server, which is active, front-ended by load balancer F5 with SSL termination on 443. Next, the presentation server, which is two. One is active standby, front-ended by load balancer with SSL termination on same 443. Then we have a central infrastructure management server 2, which is active standby with an application HA, front-ended by the same load balancer on port 443. And we have two child infrastructure management server, one for one domain and another for the production domain. And then we have the integration service, which is a 4-pair HA, primary, secondary, front-ended by the load balancer, where all the patrol agents will talk through that. So the question I have is, this is our topology. Okay, this is a big topology. We have about close to about 5,000 servers. We are trying to, do the, TrueSight performance management and the operation management. So the question I have is, when we try, how do we do the SSL enablement? The biggest problem we have is in the presentation server, when we try to add the central infrastructure management server or the child infrastructure management server, it never adds it at all. So I have to bypass the SSL and do a straight HTTP on this because there is no SSL configuration done on the infrastructure management server nor on the presentation server. Everything is terminated on the load balancer itself, the SSL. So none of the configuration in the documentation specifically talks about that.
Okay, so Prakash,
how do we achieve that?
Yeah, so that's a pretty, thanks for explaining your environment. So yes, we can make out that's a pretty, big environment you have with a lot of configuration. So one thing would like to ask you, so is it very specific, like are you folks having the load balancer also running in a secured environment? That do you want to also implement the SSL on the load balancer? Is that not happening, or is it that the TSPS and the TSIM are not able to communicate through over an SSL? Just wanted to understand that, because
it is not able to communicate over SSL. See, right now we have the interesting thing is when we add the component in the presentation server, if I add a component, it asks for whether it is HTTPS or regular HTTP. If I give HTTPS and use the load balancer VIP name so that it can go and talk to one of the TSIM server, it doesn't connect even though the service is running. However, if I bypass that and give it HTTP and give individual TSIM server, it connects.
Okay, so basically when the load balancer is trying to communicate over the HTTPS, so that is over SSL layer, so that is where you're facing the connection issues, right?
Correct.
Okay. Yeah, so this is something I think, this was one of the discussions we were in fact having internally in one of our, internal discussions over a load balancer, over a secured environment. So Prakash, is it okay, if, we would like to in fact go, try to understand the environment, and we will try to, get back on this. In the meanwhile, I'll just also ask Nilesh if he has any, updates or any. So he's one of our SMEs on the load balancer and who's joined us as a panelist. Okay. So Nilesh, would you like to take that question from Prakash and give some information?
So Nilesh, I'm going to have to unmute you. Which number are you calling on? Nilesh, let me know which number you're on, and I'll unmute you. Okay, hang on just one second, folks.
Yeah, thanks. Set.
Looking for him. I'll tell you what, so Prakash, we'll follow up with you on this, and if necessary, we'll get a case started with our Platinum engineering team to work through it, only because I can't find Nilesh here to unmute him, and I need to... Yeah, you're showing as an anonymous user, Prakash. So, or sorry, Nilesh.
Nilesh.
Yeah. Okay. Sorry about that. We'll take that one offline, Prakash, with you, and we'll get that straightened out.
Yeah. So just one question, Prakash. Wanted to just get clarification from you. So, are you using any custom certificates in your environment?
Hang on. I muted him. Let me unmute him. Go ahead, Prakash. Sorry about that.
Okay, the main thing is we are using Department of Defense certificate, which is much more stricter encryption. The challenge we have is we were able to do with every component except the infrastructure management server. So we were able to integrate with the app visibility portal, the collector, the proxy agent, then the synthetic transaction monitoring, everything, fine, except the infrastructure management server, which has the problem.
Okay. So one of the things, what we've seen from our, past experiences, yes, we might land up in this kind of issues when, so one thing maybe you need to make sure, which I believe you would have already done, but just want to reiterate, let's make sure, you have the certificates imported on both your nodes. So basically both your nodes should be having the same certificate. And if still after doing that, we are still, we are seeing this issue, then yes, that is something we need to debug, and we'll be more than glad to do that. Okay?
Okay.
So that is one thing I just wanted to let you know, that let's make sure you have the certificates imported in both your TSIM nodes. Both should have the same set of certificates.
Yes.
Okay. Thank you for that, Prakash.
Thank you.
Yeah, thank you,
right.
Prakash.
Sorry, I just want to check. Do we have any other outstanding questions in the chat window? It looks like Bruno is asking, with regards to discovery, if we migrate from 11.1 to 11.3, do you know if there is a way to import or export their credentials from the credential vault, or is the only way to manually write them again?
So with respect to the migration from the TrueSight 11 to 11.3, I'm sorry, Sid, I didn't get the question.
So it was, if you look in the Q&A window, it's from Bruno. He's talking about discovery. If you migrate from 11.1 to 11.3, is there a way to import or export the credentials from the credential vault, or is the only way to manually write them again?
That is some. Yes. Okay. So yes, 11 to 11.3. So from the credential vault, so are we talking with respect to the load balancer credential vault? So I'm not getting that part.
Okay.
So maybe, okay, because the thing is, see, when we are migrating from TrueSight 11.0 to 11.3, so we don't need to make any change with respect to the load balancer or the authentication mechanism, because from 11.0 onwards, from 11.x onwards, the authentication mechanism is, a common one. So that is RSSO. And the only change we need to make with respect to load balancer is if we are changing the load balancer itself, like the host name or the IP of the load balancer. So that is the time when we need to change the load balancer configuration as per one of the slides which I was just explaining. So any other credentials, importing everything? No, we don't need to. At least we've not done that. We've not seen the necessity to do that. But of course, if there's any other scenario that it might be talking about, then we are sure to take this offline.
Okay. So Bruno, I'm not sure if that answered your question. If not, we can. It seems to me you're asking about BMC discovery, but we may have to follow up with that separately. So if your question's not answered, just let me know. All right. I don't see any other questions that look like they haven't at least been answered or addressed. If you're on the line still and you do want to ask any other questions, please let me know and we can do so now. If not, we'll go ahead and close out the session. Oh, wait. Prakash has one more question. Hang on. And thank you all for holding on. Okay, Prakash, you're unmuted.
This is Prakash again. Sorry, one quick question about the integration service. So this is same thing with respect to the load balancer stuff. So when we add the integration service, I believe we need to specify the individual ISN nodes, right, rather than the load balancing name there as the integration FQDN.
So in the when you're adding it in the TSPS?
Yes.
Yes, that's right.
So what is that? I need to specify all the ISN nodes listed by its own host name, one by one. So when I create a staging policy, okay, to move See, the way in which we are doing is we are creating a staging service, staging integration service to start with. What is that? That is load balanced actually. So when the patrol agent initially get registered, it uses the load balancer name and it connects to one of the integration service nodes, depending upon where the load balancer sends at the time of initial check-in. And then upon the staging policy, so if we create a staging policy to move that particular staging service which initially get registered to its own phone home, which is basically an actual ISN. So in the policy, it doesn't provide, all it provides is a single integration service name or the cluster name. Okay, the cluster name is completely different from the load balancer name, right? So how do we make sure the ISN home for the patrol agents is the load balancer name after the staging policy is applied? Because there is no such setting there in the policy indicating the load balancer name there.
Yeah. Am I unmuted, Seth?
Yes, you are.
We can hear you.
So there's a couple of things. So on the basics front, you could say when you stage the ISN desirable connection to the agent, that agent would have to have a certificate that would let him have a conversation with whichever ISN you choose to point him at. There is a workaround that would allow you to identify your load balancer and kind of, for lack of a better analogy, fool TrueSight into believing it's an ISN, so that your staging policy could in fact assign agents to your load balancer as opposed to a particular ISN or set of ISNs. And the PE team's happy to work with you. I think your environment sounds kind of interesting. Those of us that haven't been involved with it, we're happy to have kind of a more direct conversation with you about your environment and some of the nuances that the DoD kind of presents to us, because obviously we've done a number of DoD environments, so we're pretty familiar with some of the security restrictions you represent, and I think a more direct one-on-one conversation, will be able to answer your questions and possibly offer some advice that will simplify that for you.
Okay. So Sid, can we reach out? You have any contacts? I can talk to them.
Sure. Yeah, absolutely. I'll make sure to follow up and get Prakash channeled into the right folks for a conversation, the right process.
I'm also working with my account manager team, Jason Shell. I think he's the account manager for us from the TSOM / digital IC operations. So. Okay.
So Prakash, I'll follow up directly with you, and we'll make sure we get connected.
Sure,
we do have a couple more questions. It looks like Kevin Collins is asking, it was stated that 750 to 800 patrol agents per integration server have been observed using a load balancer. Should the patrol agent config that identifies the event destination be the same for 1,400 to 1,600 patrol agents for a 2 TSIS cluster, and then 2,200 to 2,400 patrol agents for a 3 TSIS cluster?
I think I get it. So first, your numbers are in line. I would say large customers that have thousands of agents, the 750 to 800 makes a lot of sense for them, both historically using that number. When we used to talk to RT servers, is kind of carried over. So we capacity test them at 900, so the 750 to 800 makes a lot of sense. When we identify event destinations, it starts to play a role dependent on your choice and how you route that event traffic. So as you probably know, we support event traffic coming up that very same connection, and the integration service will provide the separation, the brokering of that event traffic from the data traffic. Others in large environments choose to separate that data from the get-go. and have the agent route the event traffic totally separate and apart from the data traffic as it comes into TrueSight. Both those models work through the load balancer configuration. The cell technologies very apt at application level HA. So in most cases where event traffic comes to integration services, there's an ability to, at an application level, cluster cells as well into a active hot standby scenario. So both support similar numbers, and I would argue that customers use the same agent counts into both. So if I have 800 agents connecting to an ISM which has a co-located cell, those same 800 agents are taking advantage of that particular cell.
Okay.
I saw a follow-up. Kevin had a follow-up about how many integration server clusters can be virtualized on a load balancer. Technically, it's how busy is the load balancer, right? If it's a software load balancer or a hardware load balancer, I haven't seen us not handle. I've seen as many as 65 ISNs, obviously segmented into groups of back-end servers servicing, some number of virtualized services, but a single load balancer handling literally all that traffic. Load balancers are pretty good about taking on large workloads.
Excellent. Thank you, Todd, for that.
Yep.
And Kevin, Prakash, everybody else, Lee, Bruno, thank you all for your engagement and questions. Folks, I'm going to go ahead and wrap it up now. We stayed 20 minutes longer, and we kept pretty much everybody on the call. So thank you, Sayan, for your presentation and for putting that content together for us. Todd and Nilesh, thank you for your support.